Hi everyone, this is Satish Ali, Civil Engineering Department. So today we are continuing the part of pumping. So previously we have ended till the type of pumping and what points you should keep or you should consider while you tend to select what type of pump you required. Okay, so now continuation part is an economical diameter. So what exactly a meaning of economical diameter? So economical diameter in a pumping main is nothing but you should select a diameter in such a way that your diameter should be cost effective. It should be less expensive and the maintenance cost is also less in that. So normally when we speak an economical diameter, what we do? We tend to reduce the diameter of that pipe itself. So what happens when you reduce an diameter of that pipe? Okay. So when you reduce in diameter, what happens here is there is an increase in the flow of velocity. Okay. So when there is an increase in the flow of velocity, what happens? It increases the cost of pumping. Okay. Although what I can say there is a the cost of the pipe is reduced by choosing an high velocity. Okay, but what it does here is it increases the horsepower requirement. Thus what it does, it increases the cost of pumping. Okay, so now the word optimum here is nothing but, so optimum diameter should be in such a way that which together the pumping cost and the annual maintenance or can say annual expenditure should be minimum. So your diameter, okay, which is being provided should be in such a way that it should be provided such optimal condition, okay, that you tend to have a less expenditure. So that is called as an economical diameter of that pipe. Okay, so diameter which is provided with respect to this condition is known as economical diameter of that diameter of the pipe. Okay, so it is nothing but which is together pumping cost and total annual expenditure cost is minimum. Hence what happens here is, if for example if you choose less economical diameter pipe, okay, then that chosen one, for example if it is an your economical diameter is say around it is 24 meter, sorry, you take it as an say around it is around a 24 centimeter diameter pipe, and if you are chosen less, so then what happens, the head loss, okay, in that what happens there is the head loss will be high and the cost pipe will be less because of you have an the economical diameter is 24 centimeter, you have chosen a 20 centimeter pipe, so naturally the cost of pipe will be less but head loss will be more. Due to that head loss, what happens there is, okay, okay, due to that what will happen there is the head loss will be much higher and the cost of pumping shall be more than the resultant saving of that in that of that particular pipe itself. Because of that head loss will be more. Next, similarly, if your economical diameter is say 24, if you are chosen more than that, if you are chosen a 30, so then what happens, so now the cost of pumping will be less but it increases the cost of pipe. Again there is a resultant, what happens there is much more quantity of water you are going to pump and the saving will be less over here. Okay, the savings will be less over here. Now, when you need to choose an economical diameter of the pump, there is a certain equation, empirical equation, that is been given as D equals to 0.97 to 1.22 under root Q. Okay, so you can choose from 0.97 to 0.112 Q. So relationship of optimum velocity here is, you need to consider an optimum velocity which lies between 1.35 to 0.8 meter per second. So rigorously, when they have made a testing, that they have worked out the velocity should be kept in between 0.8 to 1.8 meter per second. So this is a graph which is being plotted with respect to an annual cost versus a pipe size. So when they consider an economical diameter by using this equation, they have found out that it is quite effective one. Okay, there is much less of maintenance cost, operation cost. Okay, and it is much more efficient one. Next one. This is all about economical diameter of pumping main. Now the next one, there are certain point which you should keep in your mind when you select or when you locate a pumping station. That first point here is, it should be far away from that contamination zone or a pollution zone itself. Okay, it should be above high flood level always, because if you put it in a lower level, what happens during a flooding time, your pump will be submerged and it will cause damage to your pumping station. The location should be in such a way that there should be a provision of future growth and future expansion, that is can be done very much easily. Okay, and if you're placing the pump in a river, okay, it should be in such a way that you can withdraw a sufficient quantity of water during the peak duration also, and even in a dry season, okay, there should be an availability of water in that river itself. Okay, when you select this location, okay, you should consider the probability of fire hazard also. Okay, many times due to overworking and all, continuous working and all, the pumps may get fire in that. Okay, so these are the some of the points. So thank you very much. This completes your theory part of pumps. In the next video, you're going to see regarding problems on pumps itself. So thank you.